Everyone, thank you for joining me as we discuss hardware accelerated data shaping. My goal today is to share with you insights that will help you create a more performant and cost-effective storage solution. My name's Tim Amundsen. I am a customer success engineer with Pliops and have 10 years of experience in the storage and memory industry, ranging from product engineer to application engineer to field sales engineer. In our 50-minute chat together, we will discuss the growth of the DataSphere and what is needed to keep up with demand, the rise of QLC SSDs and what it enables, and we will data shaping. What is it, why is it needed, and how to do it more efficiently. And I will show you performance numbers from QLC drives with data shaping. As we have seen firsthand, the demand of data growth is amazing. IDC shared their report, the DataSphere, they called it. And in it, they said the global DataSphere will have an annual global data growth creation and replication will exceed 23%, a 23% CAGR for the next 5 years, and reach 81 zettabytes in 2025. Taking that one level deeper, Wikibon, the conglomerate of technical practitioners and consultants, forecasted that the annual flash sales will surpass that of both hard disk drives and tape by 2025. And by 2030, will reach 80% of all storage sales. So what is enabling this increase in NAND flash? It is the generational advancements year on year that increases the number of bits stored per unit silicon. About 5 years ago, the big leap came from going from planar or 2D NAND to 3D NAND. And now with the ever increasing layer counts for 3D NAND, we are adding 4 bits per cell, or QLC. Back in 2020, Intel shared their projections of cost reductions enabled by QLC NAND. They presented this plot of dollar per gigabyte and how close they are getting to nearline hard disk drive prices. But the more impressive plot is the lower one, showcasing the total cost of ownership. They project that a QLC-enabled storage solution will cost less to operate than one with nearline hard disk drives. That is truly amazing. Kioxia is also bullish on QLC because of its performance per watt and overall lower power consumption than hard disk drives, touting QLC as a green solution. Because of this, they project that QLC NAND will make up 30% of all NAND shipments by 2025. Now, QLC NAND is already mainstream. Intel, Micron, Western Digital, Kioxia, Samsung, SK Hynix either already have a QLC-enabled drive or plan to have one soon. Enterprise QLC SSDs are already available in various form factors, E1.L, U.2, SATA 2.5 inch, for easy adoption into your current systems. So why aren't all storage solutions selling today, including QLC NAND? Because there are some major limitations to QLC NAND. Performance with a random workload, endurance and lifespan, very large indirection unit, and an enormous blast radius. So with a random workload, it has a devastating impact on QLC performance. One vendor's datasheet actually calls out that you will get 1/16 the endurance of the drive if you choose to run a random workload over a sequential workload. QLC SSDs are also moving to a larger and larger indirection unit. This is the amount of data linked with a logical block address. Some of the newest QLC SSDs have 64K indirection unit. That's 16 times the standard of 4K. This enables QLC drives to have less DRAM, which lowers the cost, but you must change your software or your file system to take full advantage of that. And finally, QLC drives are getting larger and larger with 32 terabytes available now and 64 just around the corner. That is a lot of data to go down, and it will take a long time to rebuild that data, especially if you have to rebuild it across network. But I have a solution to each of these problems. We can address them with data shaping. Data shaping is the practice of taking very random data, which is hard for an SSD to manage, especially a QLC SSD, and optimizing it for that that drive. Now, no analogy is perfect, so bear with me, but imagine you have a jar of variously sized marbles. In that jar, there is a lot of wasted space. And it's also hard to move the marbles around, especially if one is no longer needed. Let's first take those marbles and make them smaller. Simply by making them smaller, we reduce the wasted space. Then we will merge them and actually reshape them so they are consistently and perfectly sized cubes. Later, we will stack these cubes to make an organized structure. That is data shaping. Compression, batching and merging, and sequentialization is data shaping. Taking very random data and writing its compressed version to the drive in perfect alignment to indirection unit and NAND block size is how we optimize data for QLC. These three pillars will give you greater performance, lower write amplification, and thus extended drive life, and much more usable capacity. But you may ask, what about that last pain point? What about the blast radius issue? I completely agree, and that is something we cannot go without. We need to have all of these points built upon a foundation of hardware-enabled data protection. Now, attempting to do these four operations on our existing hardware will bog down your CPU, will consume a lot of NAND, will require software optimizations. We need to offload all of these onto dedicated hardware. Pliops, with their extreme data processor, has brought that hardware-accelerated data shaping and protection to the market. The Pliops XDP solution will manage a full array of SSDs, presenting it as a single high-performance block device. No need to change the OS, no need to change your file system or application, just insert the card and install our API and software. And the cherry on top is that the drives that are managed by XDP are still available to the host for pulling logs, for updating the drives, and for checking the health of the drives with your existing tools. Now you're probably wondering, this all sounds good in theory, but let's see the data. So let's first look at the data protection element. Remember, this is the foundation upon which all the other operations are based on. This plot shows a MariaDB queries per second. Right off the bat, you can see that the array managed by XDP gets 2.5 times the performance of a solution that uses software RAID 0 and 5 times that of software RAID 5. Now, let's see what happens when one of the drives fails. The software RAID 0 solution cannot recover. The software RAID 5 solution hobbles along, attempting to rebuild the data. And the Pliops XDP solution rebuilds the data quickly, and the performance remains 2x that of software RAID 0, even while rebuilding. Here, I am testing 4 of Intel's latest QLC SSDs, the 15 terabyte P5316, and software RAID 0, and as an array managed by Pliops XDP. The plot shows the bandwidth of the array for a 4K random write workload. In software RAID 0, where there is no data shaping, the array hobbles along at just 90 megabytes per second. But when we manage the array with XDP, we reach the full potential of the array, and at high Q depths, achieve 48 times greater bandwidth. And now, you may argue that this is not a real workload, because no one runs random all the time, and I completely agree. So let's look at a 70-30 mixed workload. Pliops manages to achieve 47 times greater IOPS at large Q depth compared to software RAID 0. Data shaping works. We can accomplish more efficiently with Pliops' solution. Random workloads are no longer keeping you back from using QLC SSDs. Now let's talk about a real-world cloud-implemented use case of Pliops XDP. This cloud leader needed to increase their storage density per server by 3x and could not afford impacts to performance or endurance. Working with a QLC SSD vendor, we jointly architected a solution that would exceed their expectations. Their original configuration used 12 7.6 terabyte TLC drives managed by software and used erasure coding for data protection. The improved configuration used 24 15 terabyte QLC drives managed by 3 XDP cards. This tripled their usable capacity per server, but there was more benefits than just capacity. We later learned that they were seeing 1,500 data rebuilds a year in their data center on that previous config. With QLC plus Pliops, that dropped to near zero. With XDP, they were able to better keep their service level agreements with customers, save on system costs per gigabyte, and enjoy longer drive life. Jointly, we can enable QLC in applications previously out of reach, enabling the DataSphere to continue to expand unhindered. Data shaping with Pliops is how we can accomplish this. Pliops is ready to help you create a more performant solution and a more cost-effective solution. Pliops is backed by industry leaders Intel, NVIDIA, Western Digital, and Xilinx. Our Extreme Data Processor launched earlier this year, and we are ready for production applications. I would love to chat with each of you one-on-one and brainstorm together how we can create new solutions for your customers. Please reach out to us in our booth. Find me on LinkedIn or email me at timothy@pliops.com. Organizations need more data to create better solutions in less time. With QLC SSDs and Pliops Extreme Data Processor, we can keep up with the explosive demand for data, enable compute to take full advantage of it, and protect it from and make it more resilient. Thank you.